What is a resistor? A resistor can be defined as a two-terminal electrical component with the basic function of limiting the flow of current in the circuit. The standard symbols for resistors are given below. The one above is the International or Europe standard symbol, and below zigzag is the American standard. In order to explain the definition, we take the example of a pipe carrying water. The flow of water is similar to the flow of current in the circuit. The pressure difference at both the ends that causes the current to flow is considered to be the voltage. In this condition there would be a greater current. But if we create a resistance in the flow of water, the current would reduce accordingly. This can be done, for example, by narrowing the tube from one point. The resistor acts in pretty much the same way. The resistor have a much greater resistance than the connecting leads, causing reduction in electric current. The relation between electric current, voltage and resistance is given by Ohm's law. It was discovered by George Simon Ohm that the voltage is equal to the current multiplied by resistance. Current is taken in amperes, resistance in ohms, and voltage in volts. For this equation, it can easily be derived that resistance can be found by voltage divided by current. Ohm's law can be easily understood by the following depiction. The voltage is the driving force which pushes the current through the circuit. Resistance acts as the barrier of the blockage in the path of current, which results in the reduction of current through the resistor. This can be further explained by a simple circuit consisting of a voltage source and a resistor. The voltage source supplies the current, which is limited by the resistor. Suppose if the voltage is of 10 volts and the current is of 0.2 amperes, then what would be the resistance in this case? We know resistance can be found by voltage divided by current, which gives a resistance of 50 ohms. There are a lot of different resistor types. All the types have their own characteristics, applications, and construction. Fixed resistors have a fixed resistance value with a particular tolerance value. The general term resistor is most commonly referred to the fixed resistors. Fixed resistors are available in both axial and SMD packages. Variable resistors have an adjustable resistance value. The resistance value is adjusted by the mechanical movement. They can be used as variable voltage dividers known as potentiometer, and when they are used to vary the current by varying the resistance, then they are called as rheostats. The third type are the resistors having a variable resistance which is dependent on a physical quantity such as light, humidity, temperature, or voltage. They are vastly used as sensors and measurement devices. The resistors can also be divided on the basis of the construction and the resistive material being used. Wire-wound resistors are the oldest type of resistors that were ever being made and are still in use. They consist of a non-conducting core on which a resistive wire is wound. They usually have a very low resistance value, which result in a few advantages as well. They can have a fairly accurate value and are durable. But the disadvantage is the parasitic reactance which appear at higher frequencies. Carbon composition resistors are formed with a non-conducting ceramic in which the carbon particles are mixed. Just like wire-wound resistors, they are also very old. They used to be the most common resistors a few decades ago. These are still manufactured, although the properties are inferior to other types because of their ability to withstand the high-energy process. Carbon film resistors are the most common resistors used nowadays. They are made out of a non-conducting core with a thin carbon film wound around it. These resistors have very less tolerance than carbon composition resistors but have inferior properties compared to the metal and metal film resistors. Metal film resistors are similar in construction to the carbon film resistors but have a metal film instead of the copper film. They have even lower tolerance, lower temperature coefficient and a better stability. Metal oxide film resistors have even greater stability, temperature coefficient and reliability than the metal film resistors.